Hi everyone, welcome to FSI 206, how Venmo responded to the demand for contactless payments on AWS and on Amazon Aurora. I am Babali Sen, a senior solution architect with AWS, and with me I have Nick Chibotario joining in for the session today. Nick is the CTO for Venmo, and he will be talking about their architecture on AWS and how they scaled on AWS today.
Welcome, everyone. Thanks for attending this session. My name is Nick Chubutariu, and I am the Chief Technology Officer of Venmo. And I'm really grateful for the opportunity to present to you today. I hope this presentation finds you safe and healthy, especially during these unprecedented times. Today, we're going to talk a little bit about Venmo's evolution in the contactless payment space and how we leveraged Aurora and other Amazon solutions to accelerate delivering contactless payments for our customers. I imagine that quite a few of you are already familiar with Venmo, but some of you may not know us. So for those that don't, we'll go through a quick overview of who we are. We'll talk a little bit about the rapid increase in demand for contactless payment solutions, how we responded to market demand during COVID, and how leveraging AWS enabled us to rapidly iterate and bring a solution to the market for our customers. We're also going to talk about how we use AWS in general and why our AWS partnership has proven to be a key enabler for us and a differentiator in the way that we build and ship products. So just a little bit about me. As I've said before, I lead all of Venmo's technical and product organization. Before Venmo, I was the SVP of engineering at an adaptive robotics company that built artificially intelligent robots for manufacturing. I did that for just over a year, leading their engineering teams worldwide. Prior to that, I worked in a technical leadership capacity at Amazon for 5 years and Microsoft for 6 years before that. Some of the technologies that you may be familiar with that I helped develop at Amazon were Amazon Search, Cloud Drive, and Alexa. At Alexa, I was actually one of the earliest Amazonians to work on the development of the Echo Show. And I also worked on Amazon's computer vision products and technologies. At Microsoft, I developed Windows Server, Visual Studio, specifically App Insights. I was actually one of the founding members of that technology, and a few revisions of System Center. So for those unfamiliar with us, we actually started as a peer-to-peer payments app in 2009, offering our customers a fast, safe, and social way to pay. And really, our social feed is what makes Venmo unique and unlike any other payment solutions out there. We're currently used and loved by 65 million active users, and we've experienced tremendous year-over-year growth. And as our user base has grown, so as the sophistication and diversity of our products. We ship products such as Venmo debit card, direct deposit, instant transfer, and recently our Venmo credit card. We've made key partnerships, as you can see, with other well-known companies to extend our presence and market reach. And as Venmo is now gaining traction as a payment method to retailers, we also developed the ability to pay businesses both online and in store with Venmo. And all of this has not only led to exponential year-over-year growth in terms of Venmo customers, but a 1,200% increase in total payments volume over the past 4 years, which is really a tremendous achievement for us. Let's talk a little bit about AWS and Venmo. Venmo was born and grew up on AWS, so to speak. And as you can see, we not only leverage AWS core services, such as S3 and EC2, we use multiple AWS services, from databases to networking solutions to managed services. We use technologies such as Lambda for event-based scalability, for instance, Kinesis for real-time data analysis, CloudWatch to monitor our services, and so on. To us, one of the biggest advantages that AWS offers is the breadth of solutions. Honestly speaking, it's really unmatched. We want to absorb and leverage as much as possible of their cloud and infrastructure stack out of the box, so to speak, so we can direct the bulk of our engineering focus on building products and features for our customers. And honestly speaking, this has been a great approach for us. Using AWS and their suite of managed services wherever possible lets us enhance developer productivity, product scalability, and speed to market. And just, in general, it just gives us the ability to move fast. So certainly contactless payments technology is not new per se, but during the past year, the entire world has just seen surging demand for contactless payments due to the health risks posed by COVID-19. And as the pandemic began to spread, we immediately began to hear demands from our customers for touch-free payment solutions. The good news was that Venmo already had touch-free payment solutions. In-app payments are, of course, touchless. Then there's our chip-powered debit card. And what we'll talk about today are QRC-based payments. As soon as COVID began to spread, the world literally started to change right around us at an unprecedented pace. Handling cash just became toxic to many businesses. In addition to that, just staying open was and has been a change, especially for small businesses. Personally, I've seen a variety of each of these scenarios from, folks that just needed tipping to restaurants that are moving more and more towards contactless payments. A great number of them are already using QR codes to, either pay or display menus. A couple of days ago, actually, I was in a Home Depot, and I was amazed to see how big touchless is becoming. There was a sign with various QR codes that you could scan just to get product information. So this is really important, and we kept listening to our customers who desperately needed these solutions, and we saw that we really had an opportunity to help everyone from individuals to small businesses stay open and receive much needed money to continue to operate. So in just 6 weeks, we were able to develop and release a solution that enabled Venmo customers to present and share a way to receive contactless payments via QR codes, as well as pay via QRC at the increasing number of businesses that are using this technology as a touch-free payment methodology. So to go from literally zero lines of code to beta in 6 weeks is pretty awesome. So I want to extend a huge kudos to all of the extraordinary teams in Venmo and PayPal that made that happen. So let's talk a little bit about how we did this from an architectural perspective. QR code payments flow from a point of sale, as you can see, represented by the cash register, to our app payment platforms, which use Amazon Aurora as our database solution of choice. To ensure that we support as many QRC technologies as possible, we also made Code 128 standard available to support traditional linear code scanners. So QR codes with higher correction are rendered in the Venmo app, as you can see, for the cashier to scan. And once that happens, communication is secured and encrypted over HTTPS between our partners, PayPal and Venmo. And we use persistent SSL connections to interact with Aurora and the caching layer. The Venmo application leverages PayPal's QRC infrastructure to coordinate transactions with merchant point of sale systems. Venmo QRC payment APIs are deployed across multiple Kubernetes clusters, and we're going to talk about Kubernetes and how we implement that in a later slide. The Venmo QRC app actually has its own QRC name, its own Kubernetes namespace, and it auto scales based on CPU utilization, independently of our other platforms and services. The QRC app both writes and reads data from Redis and Aurora. We use Redis as our caching solution and also for our feature flagging framework. And it also acts as a message broker that's used for asynchronous processing. So, for example, sending notifications. For QRC, Aurora is our primary transactional database. And it's configured with a single writer, which is our primary instance, of course, and multiple read replicas that handle all the read-only query traffic. Diving a little deeper, just to talk about the overall Venmo construct, we also use Aurora for other key components of our solution. As an example, our identity service and our Braintree integration for large merchants. This solution architecture is very similar to the slide that we just looked at. You essentially have our Venmo P2P app deployed across multiple Kubernetes clusters. It auto scales based on CPU usage, of course. Our P2P solution also has its own Kubernetes namespace, which deploys and scales independently of our platform service. P2P application writes and reads data from Redis and Aurora. Redis is used as a caching solution. Aurora is our primary transactional database for all of our payment data. And it's configured much the same way with a single writer and multiple read replicas. You can see on the slide that we integrate into Braintree and PayPal. We use PayPal's multi-tenant services to process some card transactions. Also, Braintree is our card vault repository and is able to process certain type of transactions as well. And the integration into both PayPal and Braintree happens via a RESTful API implementation. When we began to diversify as a service, a large bulk of our payments volume is still P2P transactions. So even as we evolve into other financial services offerings for our customers, P2P is still at this point, our main traffic producer, so to speak. Our systems do get frequently tested by high velocity events like Super Bowl, Black Friday, and so on, where we have to withstand traffic spikes of 3 to 5 times our normal volume. And this is actually really important because in building our QRC application, we didn't know what the traffic pattern was going to be. And we needed a persistent state solution that checked a lot of boxes: scalability, latency, availability, resiliency, and so on. And one of the main reasons we used Aurora vis-a-vis other solutions was its speed and scalability. In literally every benchmark we conducted, Aurora was multiple times faster from a transaction processing perspective. And its ease of scalability and native integration into AWS just made it a no-brainer for us to use. So let's dive a little deeper into some of these considerations and see why we picked it. So as we talked about, the ability to autoscale as seamlessly as possible was one of our main requirements. Aurora just won hands down here. We can enable database clusters to handle sudden increases in workload. And when those events expire, autoscaling just removes unnecessary replicas, so you don't have to pay for unused database instances. We only pay for what we use. Having read replicas available with Aurora was also huge. So low latency reads is actually one of our core requirements for QRC. And Aurora replicas work really well for read scaling because they are fully dedicated to read operations on your cluster volume. From an availability perspective, we use multiple availability zones. We strive for better than 3 nines availability. I know 3 nines is standard in industry, but our target availability benchmark is 4 nines. So having redundancy on multiple availability zones was also important when we designed our solution. And we also needed the capability to retry certain operations quickly and efficiently. And just given the nature of QRC, fast retries on reads were a must for us. We needed to be able to process asynchronous workloads very quickly and efficiently to accommodate for spikes. And as we design QRC, we also use feature flags judiciously to account for failure modes in scenarios from our integration partners. So, just how extensive is our use of Aurora? Well, as I said before, it's our primary transactional database for all of Venmo's payment processing. It handles hundreds of thousands of transactions per second with $1 billion worth of daily transaction volume and growing. So, very, very big transactional database implementation. And as we talked about before, it's a highly scalable solution that adjusts the demands of our business, and scalability on the fly is something that we both need and use quite a bit. Aside from the solution choices that we made, I think it's important to state, just like with any other solution, when you're building something successful, you stand on the shoulders of giants, so to speak. So as an example, we were able to, when we built QRC, very quickly react and reuse development patterns from our direct deposit work. For instance, to enable folks to use Venmo to receive stimulus checks. And with QRC, when we made the technology choices that we made, and we looked at getting to market as quickly as possible, pattern reuse, for example, from other partnerships that and other integrations that we had done, where we had to work with different software, enabled us to work quickly and integrate QRC with key merchants and partners. One being CVS, of course, which was our first partner that we rolled out to, that now accepts Venmo and PayPal at 8,200 stores, which is actually a huge rollout to start with, and that's been really successful. So now that we have a good idea of how the solution works, how did we scale it to 65 million customers? Well, let's talk a little bit about how we use Kubernetes. We went all in on Kubernetes. We moved to Kubernetes to improve our deployment consistency across development stages, to empower developers to own more of their own application stack and increase development velocity. So developers are essentially responsible for their own deployment manifests, and they can use our custom-built code pipeline to deploy their code and codify runbooks to manage their production workloads. After the initial migration, we've optimized to meet the scaling needs for solutions like QRC. Keep in mind, as I said before, we didn't really know what the traffic pattern for QRC would be. So to safeguard that, as you can see, we logically separated instances of our platforms using namespaces to quickly and safely iterate on functionality. We have a single contour ingress and per namespace route delegation. What this provides us is a really simplicity of configuration and flexibility for dealing with service routing concerns. And with this setup, our QRC service deployment was optimized independently of any other platform concerns. What this assured us was that throughput and latency requirements were met for this very different traffic pattern that we hadn't seen before. We architected for scale in spite of resiliency issues by increasing our redundancy. So we run 3 Kubernetes clusters for API service workloads. They're each distributed across 5 availability zones. For the purposes of this chart, I've only presented three here, but I think you get the picture. So what does this mean? This means that we can lose an entire cluster without sacrificing scale requirements to service our applications. What does that mean? Some failure examples. Let's say if we have a lost cluster due to an expired TLS cert, where we deploy a bad release, which we all have, we know it happens. Or one of the clusters' DNS starts failing. This particular failover architecture addresses all of these types of failure modes without service interruptions to our customers. To deal with the risk of cluster-wide issues, we built custom tooling to be able to gracefully degrade. Our public Envoy proxies sit behind application load balancers, and the ALBs distribute traffic load across our 3 clusters to help mitigate against total loss of service. We have custom traffic management tools that allow us to override our proxy routing configuration at runtime to manually shift traffic to deal with cluster management and outages. This is manual right now. In the very near future, we plan to fully automate this by introducing help-based routing in our proxy configuration. So in practice, we can replace a cluster during peak traffic with no additional customer impact. And we're ready to deal with spikes by over-provisioning our service layer and setting CPU scaling thresholds at 50%. Given that, with the reserve capacity, we can start hundreds of new service instances in seconds, and we can scale new nodes within minutes, and we can flex between 100 to 300 nodes per cluster throughout the day. The main takeaway from this is, of course, in measuring performance, is we increased, of course, transactions per second due to QRC. And as you can see, there was about a 50% increase, when we in TPS from QRC and other service use. What's interesting to note, though, is our availability to serve linearly growing traffic while reducing CPU utilization and actually improving query response times. So this is actually pretty cool if you think about it. And we use the multi-pronged solution to get here. AWS Aurora played a key role on the compute and storage side, just out of the box. And what this allowed us to do is focus on in-database optimization initiatives around performance and scale. So, to make sure that as our transactions per second went up, our query response times stayed under a millisecond, and CPU utilization went down. So looking at query response times, for instance, even with the roughly 50% increase in TPS, we actually had a higher percentage of our queries that took less than 1 millisecond in terms of response time. So we went from roughly about 88% of our queries that took 1 millisecond to 93% of our queries that took 1 millisecond, even as traffic went up. Same with CPU utilization. Even in the face of increase in TPS, the CPU efficiencies as a result of Aurora upgrades and the index optimizations that we did to our data models resulted in CPU consumption going down. And with regards to compute and storage, what you see on this graph shows our current Aurora cluster compute and storage footprint. And we were able to unlock performance and efficiencies while running large size database clusters in AWS. Aurora storage engine scaled to the growing needs of QRC and Venmos product portfolio quite well, as you can see here. And again, this is just a recap on how we were able to actually improve performance in the face of increase in traffic. I won't drain this slide, as we covered all this. But again, these are some of the metrics that we looked at and some of the results that we saw. And even with a 33 to 50% increase in traffic, we gained both compute as well as query response time efficiencies. What does this mean for us in practical terms? As you can see here, by leveraging AWS technologies, including Aurora for both cloud infrastructure managed services, and take advantage of things like push button compute, auto-scaling, cloud nativity with MySQL, which we use quite a bit. This enables our agility consistently. And in this case, it allowed us to build a solution that went from 0 lines of code to a beta release candidate in about 6 weeks, which went live, again, as I said, to CVS on November 16th of this year. And it's continuing to go live with many merchants onboarding. Without using AWS as we have, it honestly would have been practically impossible to achieve something like this otherwise. So let's talk a little bit about what we learned from shipping an end-to-end solution like this in 6 weeks. Obviously, this has been a very successful release for us. With everything we ship, of course, we always look at lessons learned. So first, you have to be available and online. If you're not online, your customers obviously can't use your solution. Customers have choices, and we're very cognizant of that. Switching costs are low. So we always have to be prepared to scale up. There are surprises and traffic patterns change. These are things that you need to account for in both choosing a technology solution and just designing how you build software. Again, build upon the things that worked before in order to move faster than before. And we were able to do that. And just make good technology choices. Our jobs as developers are to ship delightful features to our customers as quickly as possible. So leverage what you can in terms of managed services out of the box, and empower your developers to build solutions and not have to worry about infrastructure, platform, managed services, and AWS and Aurora specifically in this case really enabled us to do that. So what's next for us? There's quite a bit on this slide, but what I'm really excited about in the future is applied science and how artificial intelligence really enhances our customer products. We want to double down on our aspects of artificial intelligence like machine learning, natural language processing, and computer vision to provide a more meaningful and valuable experience for our customers. So we're really excited about our growing use of tech like SageMaker, which really helped us accelerate our applied science roadmap. We're also really excited about AWS on Graviton True to unlock better price to performance ratios with ARM processors. We're very closely following the roadmap of RDS Proxy and Aurora Serverless, which just released. So congratulations to the team on our journey to grow the business and create value for our customers. And we have quite a few, really compelling features to release in the near as well as long term. So stay tuned. I think there's a lot of exciting stuff coming. In closing, I just want to say thank you. I know this is an unprecedented time for all of us. I want to thank you for taking the time to view the presentation. I hope you found the content valuable. I also hope you continue to stay safe and healthy. And I hope you have a great rest of the year. Thanks so much for attending.